Across the vast expanse of our solar system, moons orbit their planets in silent, seemingly humble companionship. Yet, among these celestial bodies, some moons stand out not just for their sheer size, but for their extraordinary features. Moons so remarkable, so planet-like, that they often prompt astronomers and space enthusiasts alike to wonder, why aren't these moons considered planets in their own right? To unravel this cosmic mystery, we have to start with what defines a planet. According to the International Astronomical Union, a planet must orbit the Sun, be massive enough for its gravity to make it nearly round, and have cleared its orbit of other debris. Moons, by contrast, orbit planets. But some moons are so massive, geologically complex, and unique that they challenge our very definitions. Let's begin with Ganymede, the largest moon in our solar system. Orbiting Jupiter, Ganymede is bigger than the planet Mercury. If it orbited the Sun instead of Jupiter, it would easily be classified as a planet. Ganymede's diameter stretches over 5,200 kilometers, and it's not just its size that's impressive. This moon boasts a magnetic field, the only moon known to have one, which hints at a partially liquid iron or iron sulfide core, much like Earth's. Its surface is a patchwork of dark, ancient terrain and lighter regions marked by long, grooved features, evidence of tectonic processes. Beneath its icy shell, scientists suspect a vast subsurface ocean, potentially containing more water than all of Earth's seas combined. Ganymede is, in every sense, a world unto itself. Then there's Titan, Saturn's largest moon, and the second largest in the solar system. Titan is unique for its dense, nitrogen-rich atmosphere, thicker than Earth's. When the Huygens probe landed on Titan in 2005, it revealed an alien landscape sculpted by rivers and lakes of liquid methane and ethane. Titan experiences weather, rain, and even seasons. Its surface is shrouded in a golden haze, hiding landscapes of dunes, mountains, and icy volcanoes that might periodically spew water and ammonia instead of lava. Beneath its crunchy exterior lies another possible ocean of water and ammonia, kept liquid by the heat from Titan's core. If Titan orbited the Sun, its thick atmosphere alone would set it apart from the airless rocks that make up most moons. Io, another of Jupiter's large moons, is a world of fire and brimstone. Its surface is a vivid palette of yellows, oranges, and reds, colored by sulfur and molten silicates. Io is the most volcanically active body in the solar system, its constant eruptions reshaping the landscape in a perpetual cycle of destruction and renewal. These volcanoes aren't just small eruptions either. Some spew plumes hundreds of kilometers into space. Io's intense geological activity is driven by the tidal forces exerted by Jupiter and its neighboring moons, stretching and squeezing its interior, melting rock and fueling its constant outbursts. Its dynamic surface, atmosphere of sulfur dioxide, and complex interactions with Jupiter's magnetic field make Io a world that, if it orbited the Sun, might have been classified as a planet in its own right. Europa, slightly smaller than Earth's moon, is another of Jupiter's Galilean satellites, but its secrets are hidden beneath a gleaming shell of ice. Europa is one of the smoothest objects in the solar system, its surface crisscrossed by dark streaks and ridges. But what truly sets Europa apart is the evidence for a vast global ocean beneath its icy crust. This ocean, kept warm by tidal heating, could harbor twice as much water as all of Earth's oceans combined. The possibility that life could exist in this alien sea has made Europa a focus for future exploration. Its potential as a habitat, its geological activity, and its size make Europa a compelling candidate for planethood in another context. Triton, Neptune's largest moon, is a captured wanderer, likely a Kuiper belt object that strayed too close to Neptune and was ensnared by its gravity. Orbiting in the opposite direction to Neptune's rotation, Triton is an oddity among moons. Its surface is a frozen landscape of nitrogen ice, with geysers that blast dark plumes into the thin atmosphere. Triton is geologically active, with a surface that appears relatively young and dynamic. Its retrograde orbit and similarities to Pluto suggest that, Had it not been captured, Triton might have been a dwarf planet in its own right. Callisto, the outermost of Jupiter's major moons, is another giant, almost as large as Mercury. Its ancient, heavily cratered surface tells a story of billions of years of impacts. Yet beneath this battered exterior, there may also be a salty ocean. Callisto's sheer size, internal structure, and potential for hosting a subsurface ocean make it another moon that, under different circumstances, could fit the planetary mold. Even our own moon, while smaller than many of these giants, has features that blur the boundaries. Its gravitational influence stabilizes Earth's tilt, contributing to the conditions that allow life to exist here. Its surface tells the story of the solar system's violent past, and its proximity has fueled dreams of exploration and settlement. The debate about what makes a planet is more than academic. It shapes how we explore and understand our cosmic neighborhood. When Pluto was demoted from planet status in 2006, the discussion about what constitutes a planet reached headlines around the world. If we judged celestial bodies purely by their size, complexity, or ability to support geological activity, many moons could rival or even surpass the smaller planets. In fact, the line between planets and moons is fuzzy, defined more by tradition and context than by a sharp scientific distinction. Many of the solar system's moons are more interesting and complex than some of its planets. Their potential to harbor life, their dynamic surfaces, and their unique histories make them prime targets for future missions and study. So why aren't these worlds called planets? In the end, it comes down to their orbits. They circle their parent planets instead of the sun. But in many ways, these are worlds in their own right, moons that should perhaps be planets. Their stories remind us that our solar system is full of surprises, and that the universe is richer and more diverse than our definitions can ever fully capture. As we continue to explore, perhaps the question isn't whether these moons should be called planets, but how we can broaden our understanding to appreciate the wonders they hold.